This training module is designed to give the student a foundational understanding of how three-dimensional geometry is represented in the digital world. This is a critical first step, as fire and gas mapping software relies on this data to perform its calculations and determine how detectors interact with a 3D model of a facility. By the end of the session, you'll be familiar with the four main approaches for storing this geometric data. 1. Geometric primitives, which defines complex objects as a collection of simple shapes. 2. Extrusions and revolutions, which create 3D forms by pulling or rotating a 2D shape. 3. Point clouds, which are a collection of individual points in 3D space. And 4. Tessellations, which represent a surface using a collection of smaller, uniform elements, like triangles. Performing fire and gas mapping requires the ability to store and manipulate data that describes the geometry of the three-dimensional world. Fire and gas mapping software then uses this representation of geometry to determine how fire and gas detectors interact with the 3D model. To understand how the calculations are performed, you first need to understand how geometry is represented in mathematical 3D models. The first 3D modeling method we'll discuss is geometric primitives. Most computer-aided design, or CAD, software that allows users to build 3D models of plants employs the geometric primitives approach. This technique defines complex real-world objects as a collection of well-defined primitive shapes. The shapes used in this approach include the cuboid, spheroid, cylinder, cone, torus, which is a donut shape, and pyramid. When creating a 3D space, the user builds a collection of these individual geometric primitives to define the entire space. To define a primitive shape in 3D space, you need three key pieces of information: its location, its orientation, and its size. The location is typically the coordinates of its center point, which could be given in three-dimensional space as a set of x, y, and z coordinates. The orientation is described by rotation and inclination angles. Finally, attributes like length, width, or diameter are used to define its size. A geometric primitive is defined partially by its location, which is conventionally represented by the coordinates of its center point, given in x, y, and z coordinates. For example, a 2 by 2 by 2 meter cuboid with a corner at the origin can be described by its center at x equals 1, y equals 1, and z equals 1. This is because the center is located exactly halfway along each dimension from the origin. This method allows for the precise placement of shapes within a 3D coordinate system. In addition to spatial coordinates, 3D modeling tools also use angles to describe the orientations of primitive objects. The rotation angle is the angle at which the object is rotated about the z-axis. A positive angle indicates a counterclockwise rotation from the positive x-axis. The inclination angle measures how far a surface is from being parallel to the xy plane. An inclination angle of 0 means the surface is parallel with the xy plane. The angle becomes positive as the edge farthest from the origin is elevated above the edge closest to the origin. When we define geometric primitives, we must also specify attributes which determine their dimensions. These attributes can include length, width, height, and radius. For example, a cuboid is defined by its length, width, and height. A spheroid is defined by its radius, and a cylinder is defined by its height and radius. These attributes are what make the primitives specific and unique within the 3D model.